Hello, Miss. I'm Ronald J. Barua, and I'm going to give you a description about our e-hailing company, Findes. Findes is a e-hailing company whose goal is to provide its customers a seamless and smooth way to connect with drivers and get a ride to their desired destination. They want to establish a database model in order to find out who are their best performing driver based on a rating system, which will help them to deliver high quality service to their passengers. The business rules here create the ground rules for the company, which maintains thresh, driver threshold, passenger ID uniqueness, trip status, driver driver vehicle legal validity, driver vehicle relation, and ensuring complete payments for each trip. I'll be also letting you go through the constraints and justification. The primary key and foreign key ensure entity uniqueness and join tables. Unique constraint has to prevent data duplication, not null, helps to avoid null values in columns. Check helps to restrict data values, and cardinality shows relationship between tables.
Hi everyone, let's take a quick dive into our e-hailing database system. This database consists of 7 tables: trips, drivers, passenger, vehicle, payments, rating, and reviews. This table works together perfectly to manage details, payment, driver, and passenger data, and more. I'll also explain how this database is normalized to the third normal form to ensure it is efficient and free of redundancy. First off, we talk about the trip tables. The trip tables is the centerpiece of the system. It stores data about each trip, such as driver ID, which link to the driver data, and then passenger ID, which connect to the passenger table, vehicle ID, which link to the vehicle table, which consists of registration number and car models. Then we got payment ID over here, which link to the payment table, and it consists of data like payment amounts, and then rating ID, which has the rating value for each driver, each trip, and then we got review ID, which capture passenger feedbacks over here. And then each table has a clear purpose. The driver tables ensure that we store driver-related data in one place and also track their overall rating. The vehicle tables link each other vehicle to its assigned driver, helping maintain accountability. And the payment table ensure the payment records. The rating tables store the rating value, and the review table store the feedbacks. And then the next step I'm going to explain the normalization to 3NF. The first normal form, 1NF, ensure that each table has atomic columns. For instance, in the trip tables, every piece of information like trip data and trip status is stored in its own column. And then the second form, normal form, eliminates the partial dependency. Attributes in a table depends entirely on the primary keys. For example, in the trip table again, we look back at the trip table. The payment ID and vehicle ID are fully dependent on the trip ID. So we can see that over here. And then the third normal form removes transition dependency. So driver details like driver names and license numbers are stored only on the driver tables, as you can see from here. You always want table. And then the car detail and registration detail are stored only in the vehicle table. And then in this way, the database will redundancy and maintain data integrity. So in summary, all these 7 tables are already form a well-connected, efficient e-hailing database. The relationship between these tables ensure that the data is properly organized and consistent. With normalization to 3NF, we avoid duplication and create a system that is easy to maintain and scale. Thank you for your time and feel, and I'll pass this to my teammate. Thank you.
Hi, my name is Feng Hearn, and I'll be presenting the ERD for my group project. And here's our ERD. As you can see, there are a total of 7 entities, 1, 2, 3, 4, 5, 6, 7. And I'll start from the left side here, vehicle. So you can see we have the primary key for vehicle, which is vehicle ID, and the foreign key for driver ID here is related to the driver entity over here. I'll get to that in a second. And there's a registration number, car model, and vehicle has a relationship with driver where it's a many to one relationship where one driver can have multiple vehicles and multiple vehicles can belong to one driver. And here in the driver entity, the primary key is driver ID and the foreign key is rating ID, which is related to rating over here. There's a relationship between driver and rating where one driver can have multiple ratings and multiple ratings belong to one driver, which is a one-to-many relationship. And as you can see, ratings are also related to trip, which I'll go to first. In this trip entity, there's many foreign keys, but the main primary key is trip ID. It's related to driver, it's related to passenger, payment review, and also rating. The relationship between rating and trip is a one-to-one relationship where one trip can have one rating ID and one rating ID can have one trip. And the relationship between driver and trip is one to zero or many, where one driver can have many trips, and in a trip there's only one driver. In passenger entity here, the primary key is passenger ID, and the relationship between passenger and trip is a one to one or many relationship, where one passenger can have many trips, but in a trip record there's only one passenger. And over here, we have the payment entity. Payment entity has the primary key, which is payment ID. This also has a relationship with the trip, where it's a one-to-one relationship, where one trip can have only one payment, and only one payment can belong to a single trip. It can't be two payments for one trip or two trips for one payment. And also, last but not least, we have the review entity here, which also has a relationship to trip, where it's a 1 to 0 or 1 relationship, where one trip can have 0 or 1 review only, and one review can only belong to a single trip. And yeah, that is our ERD.
Hello, my name is Azad Kabouf, and today I will be presenting our SQL script that we made for a database for an e-hailing company. So before I start anything, I will run the code itself to make sure that there are no errors. As you can see, there are 0 errors, and now I will go back to the script itself. So this database was designed to manage information related to e-hailing services. So first of all, we added drop table cascade constraint to make sure that there are no errors with the existing tables, and this ensures no duplication error occurs when running the script. So we created 7 tables. We made passenger tables, rating tables, driver, vehicle, payment, review, and trip table. So let's take a look at the passenger table. Passenger table holds passenger ID, which is a primary key of this table. Then it has passenger name and passenger contact number. As you can see here, passenger name, passenger contact number has a not now constraint, which means that it must have a value. So next, let's take a look at the rating table. So rating table holds rating ID, which is a primary key, and rating value, which is in between 1 to 5. And lastly, let's take a look at the trip table, which acts as a junction table. So as we can see here, trip table has a lot of foreign keys and they connect. Trip table connects to like driver table, vehicle table, passenger table, payment table, rating table, and review table. And after we created all the tables, we inserted data to them, as you can see right here. So let's take a look at the passenger table. So passenger table holds all the passenger information, including passenger ID, passenger number, and passenger name. Then let's take a look at the rating table. Rating table holds a value of rating ID and rating value itself. So as you can see, all table has information in it. And then we wrote a script to show all the table in 3NF. That's it from me. Thank you for your attention.
Good day, my name is Yongwei. In these presentations, I will walk through the 6 SQL queries we have done. The first query, we use left outer joins between the driver, vehicle, and trip tables to retrieve the driver name, vehicle ID, and trip status. This query ensures that we get all drivers, and even if they don't have a vehicle or haven't completed any trips yet. It joins the driver table with vehicle based on driver ID and the vehicle table with trip based on vehicle ID, and ordering the result ascending by the driver's name. And second query, we join 4 tables to calculate the total number of completed trips and the total payment received by each driver by using count and sum functions. The query groups the result by driver name and output the number of trips completed in descending order. And the third query, retrieve passengers whose names start with J and contact numbers are exactly 10 digits long. We use the like operator to filter name beginning with J and the length functions to ensure passengers with a valid 10 digits contact number are included. And the fourth query selects trips that are either complete or cancelled, but only for cancelled trips that have a payment amount greater than 0. The query uses an OR conditions to include all completed trips and an AND conditions in a subquery to select cancelled trips where payment has been made. In the fifth query, we use nested subqueries to identify drivers who have completed trips in a specific vehicle model called Toyota Corolla, and the outer query filters drivers whose IDs match from the subquery, which first selects complete trips from the trip table and then filters those trips to only include where the vehicle model is Toyota Corolla. And the final query lists drivers who have completed the most trip in the last month and have a rating of 4.5 stars or higher. It joins the driver trips and rating tables, filters for completed trips in the last month, and ensure the driver's rating is at least 4.5 stars by using the toNumber functions. The result is grouped by driver name and rating value, and the total trips completed is ordered by descending. And all the results should be match what we have done in the SQL code. So this is the result, and that's all from me. Thank you.